Today we're looking at 7 selected questions from one-dimensional motion. These are challenging questions. So let's jump right into it. Here's the first one. A coin is dropped from a hot air balloon that is 300 meters above the ground and rising at 10 meters per second. So the balloon is at a height of 300 meters from the ground and the coin is dropped from it. The balloon is rising at 10 meters per second. That means the initial velocity of the coin is 10 meters per second. The acceleration due to gravity is negative 9.8 meters per second squared. So we have these two quantities, and A, we are asked to find the maximum height reached. So we know that when the coin is let go, because it has an initial velocity of 10 meters per second, it's going to go up a little bit, hit the maximum height, and then come back down, as the diagram shows here. So the coin starts its journey from here, it goes straight up, reaches a maximum height, and then falls to the ground. So if we can find this displacement, we just need to add that to 300 meters, and we will get the maximum height of the coin from the ground. In order to do that, we have the initial velocity, 10 meters per second, the acceleration due to gravity. We know that the final velocity at the maximum height will be 0. That's a very important point. And we are going to calculate delta y, which is the displacement along the y-axis. The equation that fits this occasion is v squared is v naught squared plus 2a delta y, and when we substitute the numbers and calculate, you get delta y as 100 divided by 19.6, which is 5.1 meter. So now add the 300 to the 5.1 meter, we get the maximum height as 305.1 meter. In the B part, we have to find its position and velocity 4 seconds after being released. So now the time is given. Time is 4 seconds. We have the initial velocity already given as 10 meters per second and the acceleration due to gravity. So here are the given quantities. The equation now is delta y is v naught t plus 1/2 a t squared. V naught is 10, so 10 times 4 plus 1/2 times negative 9.8 times 4 squared gives negative 38.4 meter. And so to find y, we got to go 300 minus 38.4, which gives 261.6 meter. Now one thing, what does that negative 38.4 meter show? It shows that in 4 seconds, the coin has already reached the maximum height and it's on its way down. That's why we get negative 38.4. So the height is less than 300 meters. That's why we got 261.6 meters. Now to find the velocity, similarly use this equation, v is equal to v naught plus at, and we will get the answer as negative 29.2 meter per second. Once again, the velocity is negative, showing that at that time the object is moving downwards. Now the C part. We have to find the time that the coin takes to hit the ground. So what's the displacement now? The displacement from here until it hits the ground is negative 300 meters because it's going down. So we know delta y, we know the initial velocity, the acceleration to gravity, and we can use the equation delta y is v naught t plus 1/2 at squared. Okay, so here is the thing now. So when we do that, delta y is negative 300. So negative 300 is 10t minus 4.9 because it's half times negative 9.8. We get a quadratic equation. We have to solve the quadratic equation using a minus b plus or minus square root of b squared minus 4ac by 2a. I know that's a mouthful, but you got to look that up. A is 4.9, b is negative 10, c is negative 300. And when we use the quadratic equation, we get the time as 8.91 seconds. Here's the second one. In this question, an object is dropped from the roof of a building of height h. During the last second of its descent, it drops a distance h by 3. Calculate the height of the building. Now, problems such as this can really be frustrating because you do not have any numbers. It only gives you two quantities, that the height of the building from which it is dropped is h, and during the last second of its fall, it drops a distance h by 3. And from there, we have to calculate the height of the building. So in this case, we got to have two equations in which we have h and t as unknown quantities and then solve the two equations. We do know that the initial velocity of the object is 0 because it's dropped. And therefore, when we use this equation, delta y is v naught t plus 1/2 gt squared. The first term vanishes, this term becomes 0. So you only have h is equal to 1/2 gt squared. Okay? That's one of the equations. Now, we also know that in the last second, it traveled a distance h by 3. That means in t minus 1 seconds, it did travel h minus h by 3. Did that make sense? Because the total height is h. In the last second, it travels h by 3, which means in t minus 1 seconds, it traveled the remaining height. H minus h by 3 is 2h by 3. So once again, when we use this equation with v naught is equal to 0, you're going to get 2h by 3 is equal to half gt minus 1 whole squared. That's the distance traveled in t minus 1 seconds. So now we have the two equations and we can substitute one into the other. We can take h is equal to 1/2 gt squared and substitute it here, which is what I'm doing now. And then you see that on the right side, you just leave it as 1/2 g t minus 1 whole squared. And then you simplify by cancelling out 1/2 g from both sides. So you have 2t squared by 3 is equal to t minus 1 whole squared. And so there's only t in that equation. Solve for t. You get this 2t squared by 3 minus t squared plus 2t minus 1 is equal to 0. You got to look at that carefully and rearrange to get this quadratic equation and then find the root of the quadratic equation. Once again, using minus b plus or minus square root b squared minus 4ac by 2a. And when you do that, you get t is equal to 5.45 seconds. Once you get the time, we can substitute it into this equation to get the height as 1/2 times 9.8. Technically, it should be negative 9.8 times the time squared. That gives the height as 145.5 meters. This is question number 3. In a 100-meter race, the winner is timed at 11.2 seconds. The second place finisher's time is 11.6 seconds. How far is the second place finisher behind the winner when she crosses the finish line? Assume that the velocity of each runner is constant throughout the race. Alright, so now you have the winner taking 11.2 seconds. The second place finisher takes 11.6 seconds. So first what we do is we find the average velocity of the second place finisher. Velocity is displacement by time. that is 100 meters divided by the time, which is 11.6 seconds, gives 8.62 meter per second. That's the average velocity of the second place finisher. Alright, now the displacement of the second place finisher in 11.2 seconds. Why 11.2 seconds? Because that's the time that the winner took. So in 11.2 seconds, the second place finisher is 8.62 times 11.2 seconds, which is 96.55 meter. So the second place finisher has only covered 96.55 meter. Therefore, by how much is the second place finisher behind? It's going to be 100 minus 96.55 meter, which is 3.45 meter. In number 4, the position of a particle moving along the x-axis varies with time according to the equation xt is equal to 5t squared minus 4t cubed. Find velocity and acceleration of the particle as functions of time. So let's take it one by one. We're given the displacement, x is the position, and to find velocity you have to take the derivative of that. So velocity is dx by dt. So when we use calculus and find dx by dt, we get velocity as 10t, because 5t squared is 10t and 4t cubed is 12t squared. So you get that, and then acceleration, to get acceleration, once again you take dv by dt. So take the derivative of this, which gives us 10 minus 24t. That's how you find the velocity and acceleration as functions of time. And then the B part, we have to find the velocity and acceleration at t is equal to 2 seconds, which is really simple. Just got to substitute the time as 2 seconds in these equations. So velocity, you get it as negative 28 meter per second. And then when you plug in t as 2 seconds here, we get negative 38 meter per second squared. Now the C part is interesting. It says the time at which the position is a maximum. Now how do you find the time at which position is a maximum? We know that dx by dt is the slope. When the slope becomes maximum, you know that at that point, at the highest point, the slope is actually 0. At the highest point, the slope is 0. So that's what we're going to do. So we either at time t is equal to 0, this could happen, or slope should become 0. We'll go for the second part. So we'll set the slope. We know that the slope is the velocity. So we set the slope as 0, or rather the velocity is 0. So velocity 0 is equal to 10t minus 12t squared from this equation. Solve for time. You get the time as 0.83 seconds. Okay, and at 0.83 seconds, we have to find the maximum position. So at t is equal to 0.83 seconds, if you substitute into this equation for x, which is 5t squared minus 4t cubed, we will get the position. That's what I've done here. Substituted the time as 0.83, and I get the displacement, or the position rather, as 1.16 meter. In question 5, a cyclist sprints at the end of a race to clinch a victory. She has an initial velocity of 11.5 meter per second and accelerates at a rate of 0.5 meter per second squared for 7 seconds. What is her final velocity? Okay, the initial velocity is given. That's 11.5 meter per second. Acceleration in time, so it's v is equal to v naught plus at, and then just plug those numbers, 11.5 plus 0.5 times 7, you get the final velocity. Okay, so that we get as 15 meter per second. In the B part, the cyclist continues at this velocity to the finish line. If she is 300 meters from the finish line, when she starts to accelerate, how much time did she save? Now, got to be careful with this. So the cyclist continues at this velocity to the finish line, but when she is 300 meters from the finish line, she decides to accelerate. How much time did she save because she accelerated? Let's do that. So delta x is v naught t plus 1/2 at squared is the equation. And in this equation, the initial velocity is 11.5, time is 7 seconds. So we're trying to find out how much distance the cyclist covered before she began to accelerate. That's why we're using 7 seconds. So we get that as 92.75 meters. So now 300 minus 92.75 meter happens to be 207.25 meter. So 207.25 meter was covered at that velocity of 15 meter per second. Remember that we got the velocity of as 15. So she traveled this distance at this velocity, which will give us the time. So she took 13.82 seconds. Now the total time is 13.82 plus 7 seconds, which is 20.82 seconds. I hope that made sense. We know that she had already taken 7 seconds. Now we found out that at this average velocity she would take 13.82 seconds. So the total time is 20.82. Now let's go to the C part. In the C part, the second place winner was 5 meters ahead when the winner started to accelerate, but he was unable to accelerate. So the second place winner was ahead, but he was unable to accelerate and traveled at 11.8 meters per second until the finish line. So what was the difference in finish time in seconds between the winner and the second place and the runner-up? Okay, so to find that, we have this distance given as 300 meter. 300 divided by 11.5 gives 26.09 seconds. So the time saved was 26.09 minus 20.82 seconds. How do we get that? So second place finisher took 26.09 seconds. The winner only took 20.82 seconds. So the difference is 5.27 seconds. And then the time for the runner-up is 295 divided by 11.8, because that person is only keeping 11.8. That's 25 seconds. So the winner finished 25 minus 20.82, 4.18 seconds ahead. All right. And then to find how far back the person was, just got to multiply this difference in time, which is 4.18 seconds, with 11.8. And you get it as 49.32 meter from the finish. 6. In 1967, New Zealander Bert Munro set the world record for an Indian motorcycle in Utah of 295.38 km per hour. The one-way course was 8 kilometers long. So you're given the velocity, you're given the total distance, and the acceleration rates are often described by the time it takes to reach 96 km per hour from rest. And if this time was 4 seconds, so that means Bert took 4 seconds to accelerate from 0 to 96 km per hour. First of all, you see that all the units in this question are messed up. You cannot work out the problem in kilometer per hour. you got to change it into meter per second. Okay, so to find the acceleration first, we got to change 96 kilometer per hour into meter per second. How do you do that? 96 times 1000 divided by 3600, because 1 kilometer is 1000 meters and 1 hour is 3600 seconds. That gives 26.67 meter per second. And so the acceleration is 26.67 divided by 4 seconds. You get it as 6.67 meter per second squared. And then the velocity, likewise, is 295.38, but given in kilometer per hour, so that's got to be changed into meter per second, and you get it as 82.05 meter per second. Alright, once you get that, we can now find the time to accelerate, because this person accelerates to the maximum speed, and that time is going to be simply change in velocity by acceleration. We know that the velocity is 82.05, but the person started from 0, so the change is 82.05 minus 0 divided by the time taken, divided by the acceleration, so 6.67, so that gives us 12.3 seconds. That's the time to accelerate to maximum speed. Alright, so the distance that the person covered during the acceleration, is delta x is equal to 1/2 at squared. Because the initial velocity is 0, we do not have that term of v naught t. So that gives 1/2 times 6.67 times 12.3 squared, which is 504.55 meter. And the total distance was 8 kilometers, which is 8,000 meter, right? So now we got to take 8,000 minus the 504.55 meter, which gives us that big number, 7,495.44 meter, which is the distance that was covered at a constant speed. And so now we can find the time for this distance simply by dividing this distance by the speed, which is 82.05. That gives 91.35 seconds. So 91.35 seconds was traveled at constant speed, and then 12.3 seconds was the time during which he accelerated. When you add those two times, you get the total time as 103.65 seconds. Here is the seventh and the last question. A police car waits in hiding slightly off the highway. Oh, that's dangerous. A speeding car is spotted by the police doing 40 meters per second. At the instant the speeding car passes the police car accelerates from rest to 4 meters per second squared to catch the speeding car. How long does it take the police car to catch the speeding car? So we have to find the time that it takes the cop to catch the speeding car. That's number one. Number two, there are two objects here. One is the speeding car, the other is the police car. And by the time the cop catches up with the speeding car, we know their displacements have to be the same. That's the idea. The main idea is that the displacements have to be the same. Third, the speeding car is moving at constant speed while the police car is accelerating. So the equations that we use are going to be different. For the speeding car, displacement is just going to be the product of velocity and time. Alright? And the velocity is given as 40, so x is 40 times t for the speeding car. But for the cop, since he is accelerating, we have to use x is equal to v naught t plus 1/2 at squared. But v naught is 0 because the cop was initially at rest. That's why that term is missing. And then we have 1/2 times a t squared. A is 4, so that gives us x is equal to 2t squared. So once you have these two equations, We know that the x's are equal, so set the right hand sides equal to each other and solve for t. And you get the answer as 20 seconds. So it took the cop 20 seconds to catch up with the speeding car. And here is a diagram just trying to show you that the speeding car is moving at a constant velocity. The dots are equally spaced, while for the cop you can see that the spacing is becoming greater. So here are these 7 questions, and I hope you understood how I explained the way, the method, and the means of working out these problems in kinematics. It needs a lot of patience and in fact a lot of courage to do problems like this. But don't get frustrated, you're going to get this by practice. Wish you all the best and see you in the next video. Thank you.